Hi, fourth graders. It's Mrs. Van Boxtel, and I thought I would just pop on and say hello and welcome everybody today before we jump into our math lesson. So good to see everybody and glad you're here. And we'll go ahead and get started. So for today, all of us should be caught up through student book page 234 and Home Connections page 122. And this also goes along with making sure that your Google Math slideshow is updated through these pages as well. Next, I'd like to send out a thank you from your fourth grade teachers, from all of us, for doing such a nice job with all the virtual learning videos we're sending your way and all the different assignments, and just really being flexible and continuing on with a positive attitude and just really all trying our best. So a thank you from all of your fourth grade teachers. So students, today we're going to be continuing on with Unit 6, our multiplication and division, data and fractions unit. We're going to continue with Module 2, revisiting area and perimeter. And for today, our session 5 is an area and perimeter checkpoint. And we're going to be doing it a little bit differently virtually compared to how we would have done it in the classroom. So it'll look a little bit like this. Throughout the checkpoint questions, and we'll try to get through as many as we can, and I'm going to be aware of time as well. We might not get to all of them. We'll just do our very best. And what I'm hoping is you'll pause the video, give yourself some time to solve the problem using some different strategies that you know work really well for your learning, and work out the problem. And after you think you have, then you can continue the video, see what type of strategy I'm sharing, a possible way to solve the problem, and then also check in with the answer to see if you were accurate with your answer. And then we'll move on to the next problem, and you can again work it out, pause it, and then we'll press play again and kind of go through that process again. So that's kind of the big idea with the work that we're going to be doing today. But before we jump into that, I thought we'd have a little bit of fun together and take a look at some math jokes. So here goes our first one. Who's the king of the pencil case? Got any ideas? It is the ruler, of course. Next joke. Why is the obtuse triangle always upset? Any ideas? Well, because it is never right. All right, on to the next joke. Why did the two fours not want any dinner? All right, let's see what the answer is to that joke. Because they already ate. And I did save the last joke for last. Oops, let's go ahead. Here's the best one of them all. What did the 0 say to the 8? Any ideas? Let's take a look. Nice belt. Now that one did take me a little bit of time to figure out, but I did like that one once I got it. All right, feel free to share these jokes with your family and have fun with them. All right, moving on. Here is our Unit 6, Module 2, Session 5 agenda for today. We are going to start by looking at some vocabulary that we've had really throughout Unit 6. We'll take a look at our area and perimeter checkpoint practice problems. Again, you're going to want to pause the video maybe now. Make sure you have paper and pencil ready, or if you have a slate, that would work out just as well. After we go through and I model and you practice some of the strategies for our checkpoint practice problems. You will have an assignment to try on your own. It is student book page 235. It's titled Frederico's Fort. And at the very end of the video, I will include the answer key to this student book page so that you can check the accuracy of your answers and go back and make any changes to any of the problems that you may need to if you're realizing that you were off track with some of your answers. And there are no home connection pages for this session. All right, I have a little visual down here that is reminding us the difference of perimeter versus area. So if you want to check out that little visual as well. All right, we'll take a look at some vocabulary. Today's vocabulary work. First of all, again, our handy dandy vocabulary word area. And remember, it is the total number of square units needed to cover a two-dimensional surface. And we have some nice examples, some nice visuals, some nice models of that in this picture as well. Next vocabulary word, array. An array is an arrangement consisting of equal rows and equal columns. And we have some different examples of arrays here that you might want to use as you work through some of the problems today or in the future as well. Another one of our important vocabulary words, dimension. Length, width, or height of a figure. For our fourth grade purposes, we deal with flat, two-dimensional shapes that would have the dimensions of width and length. Looking ahead to fifth grade, you're going to move more into three-dimensional figures and work with those, and then you would have that additional dimension of a height. But for us, this is where we're going to find our most handy model of our area model, where we're going to need our dimensions to use as a strategy to solve some of the problems that we'll work with today. Our next vocabulary word, perimeter, and our visual to go along with that. Perimeter is the distance in linear units around a two-dimensional flat figure. The perimeter of a circle is called the circumference. Continuing on. A ratio table, and we have an example of a ratio table can go in a horizontal fashion, or it can also go in a vertical fashion. It's just kind of preference, whatever works best for your brain. So a ratio table is a model that represents equivalent ratios, can be used as a tool to solve problems that involve multiplication, division, fractions, and proportions. All right, continuing on with our vocabulary words. Our next one is rectangle, a two-dimensional flat shape with two pairs of parallel sides, 4 total sides, and 4 right angles. When we are solving multi-digit by multi-digit multiplication problems and we want to use the area model to help us solve it, we are really using a rectangle to do that, and sometimes even breaking the rectangle into smaller area models to help us solve those more challenging multiplication problems. And our last vocabulary word for today is unit, which is just another name for one. The unit columns is the same as the ones column. And here again is a model of a unit with our base 10 pieces. And if we're looking at a number in standard form, in this example, the 4 would be the unit, also known as the 1. 4 ones in the number 814. All right, continuing on. So today we are going to be looking at a variety of story problems, also known as word problems. And we know that it's helpful when we are working with story problems, we use our seal of approval. And the S stands for using a strategy. Now, the cool thing about the math that we do at Riverside is exploring and using and practicing all different types of strategies and being open to looking at and learning new strategies, and then trying to figure out what strategy makes most sense to your brain and using that strategy to find your accurate answer. And eventually, you might find one that works better for you, and you might want to use that one more than the rest. And if the story problem or any problem doesn't say solve using this strategy, you can really be creative and you can really try to use any of the strategies we've worked on all year. So that's kind of a cool thing, and absolutely keep that in mind moving forward. So in addition to using a strategy to solve our story problems, we also want to remember to show and use equations to help us solve our story problems. And eventually, using our strategies, drawing out our strategies, writing out our equations will help us lead us to the correct answer. That's where we have the A in our seal of approval. And then lastly, after we've gone through our strategy and worked the problem out, maybe had a couple of equations in there to help us as well, getting to our answer, we want to make sure that we label our answer correctly. In the case of perimeter, which has been a focus lately for us, we want to make sure that we're just labeling our perimeter answer in linear units. For example, the perimeter is so many inches, so many centimeters, so many miles. Whereas if our answer is in area, we want to make sure that we're labeling it in square units, square inches, square miles. All right. So we are ready to jump into our first area and perimeter checkpoint problem. So here's our first problem. We're going to look at it together. And what I'm going to ask you to do is then, after we look at the problem together, kind of maybe even get started on it, absolutely give it a pause, solve it on your own, and then come back and see what the answer is. And then I'll lead through a possible strategy that you may have used, or you may have used another strategy, and that's cool too. Problem 1. Find the unknown dimension of a rectangle if its area is 216 square miles and one dimension measures 6 miles. Use labeled sketches and equations to model and solve this problem. Show your work. Label your answer with the correct units. So again, showing your work means whatever strategy is going to work out best for you. All right. So this might be a point where you're going to want to pause, try to solve it on your own, and then come back and see if your answer was an accurate, correct answer. All right, let's take a look at the problem. So I'm going to start by using an area model, drawing my big rectangle, and I know that here it tells me my inside is 216 square miles. So I'm going to start recording some of my known information. And it's also telling me one of my dimensions is 6 miles. So I'm going to label this dimension, my width, 6 miles. So what I'm eventually trying to solve for is this unknown dimension here. Now, if I think about equations that I could use for this area model, I could use 6 miles times my unknown equals 216 square miles. Or I could do the turnaround fact. My unknown dimension times 6 is 216. Or I know that I can also use my area model as a division problem. This would be 216 square miles divided by 6 miles equals my unknown, or 216 divided by my unknown equals 6 miles as well. So this would be my strategy in my seal of approval. My strategy that I'm using is my area model that I just sketched out for you. Here are some possible equations that could help me solve that problem, because what I want to find out is this unknown dimension, just like it's asking down here. So I'm going to do a little bit of erasing so I have some more space to solve my problem. So for me, in my brain, I know that trying to figure out what number times 6 equals 216, that's a little bit too hard for my brain. Or 216 divided by 6. I don't know that fact off the top of my head. That's not one that I have memorized or one that I have known. So what I'm going to want to do is I'm going to want to take this 216 and I'm going to want to break this into some friendlier numbers so that I can work with. So what I would think about is, I know that 216, I could break it into 216, but from there, if I look at using friendlier numbers and using powers of 10, this 20 divided by 6, that's not going to work out for me. And this 16 divided by 6, that's not going to work out and be easier numbers for me. So maybe I would try 190, because I'm still breaking 216 up. 190 plus 26. Again, this 19 is not going to divide equally into 6, or this 26 is not going to divide equally into 6. So sometimes some of these strategies, you really have to just go about it using a little bit of trial and error. So I'm going to try now 180, and I would need to add 36 to equal my 216. So this seems like it could be a really good possibility. I can see 18 divided by 6. That would work out for 3. And 180 divided by 6 would be 30, using that 0 trick, if you will, or that power of 10. And then 36 divided by 6. That's an awesome one, or 6 times 6 would be 36. So I'm going to go with dividing up my 216 into these two friendlier numbers. So from here, what I'm going to need to do is divide my larger area of 216 into 180 square miles and 36 square miles. From here, I've already worked this out. 18 divided by 6, or what number times 6 is 18, is 3. Then I have my 0, so for the 30. So in here, 30 times 30 times 6 is 180. And then here, 36 divided by 6 is 6, or 6 times 6 is 36. And all together, I have my 216 square feet, or square miles rather. So this dimension here is 6 miles. Now this dimension here is 30 plus 6 for 36 miles. So my unknown dimension is 36 miles. Again, because 36 times 6, or 6 times 36, is 216 square miles, or 216 divided by 6 is 36, or 216 divided by 36 is 6. So that would be one possible way to go about finding our unknown dimension. And you could have used a different strategy as well. That's awesome if you did. And our answer is 36 miles. That would be our other dimension. All right, let's go ahead and erase this work for this problem, and we'll move on to our second problem. Again, after we look at our problem, you might want to pause and solve it on your own, and then come back and see if your answer was accurate. So here we go. Problem 2. Find the unknown dimension of a rectangle if its perimeter is 254 meters and one dimension measures 6 meters. Use labeled sketches and equations to model and solve this problem. Show your work. Label your answer with the correct units. So we are trying to find the unknown dimension of a rectangle. So you might want to pause, work it out a little bit, use your seal of approval, and then after you think you are set, press play again, and then check back in with us. All right, let's take a look. So again, let's sketch this out by making our rectangle. And understanding for this problem, we're talking about the perimeter, the distance around. It's telling us that the perimeter is 254 meters in all, and one dimension measures 6 meters. So with a rectangle, if I know this side, I know the dimension, or I know the length, in this case the width, of the other side, which would also be 6. So from here, I'm trying to figure out really what this side measures in its length, and then realize that that's doubled down here. So I could look at it like, all right, I'm trying to get up to this side plus this side plus this side plus this side is going to equal 254 meters. All 4 sides added up are going to equal 254. So what I'm going to do is I'm going to take my 2 6s, add them together, double them if you will, and get up to 12. So from there, I can take my 254 and subtract 12, which will be 242. So now I know that these 2 dimensions need to equal together 242. So what I can do is have 242, and that would get me to 121 meters. So this dimension is 121, this dimension is 121. So if I add 6 plus 121 plus 6 plus 121, that would give me my 254 meters in perimeter. So the unknown distance is 121 meters. Again, my seal of approval. I had my strategies, I had my equations, I had my answer, and I have my label. All right, you can look at that one a little bit. Maybe you used a different strategy and it worked for you and you still got the same answer. Maybe you used some different equations and you still got to the same answer. That's all cool stuff about math. Now I am starting to get a little bit worried about this video going on too long. So I'm going to kind of stop there. And I think we had a chance to really look at 2 really good problems and work through those. And I'm going to go back to I'm going to go back to our agenda. And from here, I'm going to have you take a look at your student book page 235, titled Frederico's Fort. And it looks like this in your yellow student book. And this is going to be your independent math assignment today. And when you do complete it, you're going to take a picture of it and you're going to add it to your Math Google slideshow. Those of you that have been writing the dates on those slides with the unit and the module and the session number, that's been extremely helpful. So please continue to do that as well. And after you finish your student book page 235, here it is. It's just one page today. I want you to come back and check in with the answer key. So it's kind of on the honor system here that you're going to do the best that you can with student book page 235. And then after you work through these problems that I just kind of scrolled through with you, and when it's okay with your family, then you can pop on and take a look at the answer key. So this will probably be a good place to pause, because now I'm going to move on and show what the answers are to your student book page 235. All right, so at this time, I'm assuming you had a chance and some independent work time on student book page 235, and now you're back to see how you did with the accuracy of these answers. So let's walk through that, and you can check your work. So here we go with Unit 6, Module 2, Session 5, student book page 235, Frederico's Fort. So for problem 1, the answer would be 266 square feet. Again, that labeling is important since we're talking about area. Your answer does need to be in square units, in this case, feet. And then, of course, the work will vary depending on what type of strategy you use to solve the problem. For problem 2, are you disagreeing or are you agreeing? And why? This is what Frederico is saying. Do you agree with him? Yes, Frederico is correct. And your work will vary. And then this is one way to explain using our doubling and halving strategy that we've been familiar with for quite a few units now. And again, absolutely, the cool thing about these videos is you can pause whenever you need to pause and then continue on when you need to continue on. Okay, problem 3. 1,540 square inches. Again, it's squared because you're answering what the area is. And your work will vary. That's because everybody's using different strategies, exploring with them, figuring out which strategies work best for different problems, which strategies work best for your learning. And then lastly, we have fill in the blank, where for some of these, we're trying to get to friendlier numbers. It could be the over-under strategy that we've worked with in the past. Could be the distributive property that we've looked at in the past. Could be doubling and halving strategy that we've worked with in the past as well. All right. So again, class, thanks for watching the video. Thanks for hanging in there with me and doing your very best work. And the cool thing is you can go back and review some of these problems, take a look at the answers, and if you need to, see where some of your mistakes are or were, and then learn from there. So until next time, This is Mrs. Van Boxtel saying happy virtual learning, and I hope that we can get together real soon and see each other. Bye, have a good day.